Study of the population of a rare marsupial found the population growth rate was 9.5% per annum or per year. At the commencement of the study, at the start of 1997, the population was 2,000. So part A, write a recursive formula for predicting the population P, T years after 1997. So for this one, it's a recursive formula. So we might say, I'll use P n plus 1 is going to be equal to Pn, the previous term, and I need to multiply by some number here. Now, remembering your 9.5% increase, even though you're increasing, it's not an arithmetic sequence, it's a geometric sequence. You're actually, the start of each year, you're at 100%, and you're increasing by that 9.5% to go to 109.5%, which means that you're multiplying by the decimal equivalent of 1.095. So in fact, you're multiplying by 1.095, and of course, anytime we're finding a recursive rule or recursive formula, you need a P0 or a P1 value. So in this case, P0 is equal to 2,000. There's our recursive formula, and just understanding that you're multiplying, so it's a geometric sequence, not an arithmetic sequence for these percentage increase or decrease ones. Okay, so next part of the question says predict the population at the start of 2007 to the nearest whole number. I guess for this one, start of 2007, first thing you've got to work out is, which sort of n value do you want here? That's kind of the key part of this, I guess. And I would suggest that you might even, say 1997. That's when n is equal to 0, and just start counting up so you get a feel for what's going on. 1998, n is equal to 1. 1999, n is equal to 2. Whoops, that's not right. 2000, n is equal to 3. 2001, n is equal to 4. Now, if you really wanted to make sure of it, you could keep going to 2007 and get the right n value. But by this stage, you're sort of figuring out, okay, 2000 take 1997 is 3. 2001 take 1997, n is equal to 4. You can see what's going on here. So in 2007, you just go 2007 take 1997, that's 10. So really what we're after here is P10. What is that value? Okay. Now, at this stage here, I'd be suggesting, rather than doing all the calculations, I guess we could do that on a calculator pretty easily in main menu. You could go into main menu here, and maybe go, starting off with 2000, we're timesing that by 1.095. Get that answer there. Then you might go, I'll bring up the keyboard and say answer times 1.095, and then if you just keep pressing execute, you get the terms of the sequence. So you can see there's our, I'll do it a couple more times maybe. I'm just going to resize the screen a little bit here. I'll just move it up a bit. Resize that screen. Oops, try that again. What's going on there? Come on, resize there. What's going on? I'll get rid of the keyboard and that'll work. There we go. So you can see there's P1, P2, P3, P4, P5, P6. You can keep going all the way to P10. Alternatively, you can actually put it in as a in sequence menu, which is probably what most of you like to do. So we'll go menu and then sequence. Now notice this one here is you've got a P0 value there. So you want to make sure the type's right. You want the type to be A0 here, or A0. So we've just got to type here, change that to A0. We've got the right format now. I'm going to put, instead of PN, I'm going to put AN obviously. So just go up to there, pop in AN, times by 1.095. There's the recursive rule with a first term of 2000. Then we can just go in here and, what's going on here? No sequence is selected. Better tick that box and try again. It's just taking a little while there. There we go. So you can see there's your initial value 2000. You can just scroll down to the 10th one. There's our answer right there. So we got an answer there of 4,956.46. And we want it to the nearest whole number, so you're just going to round that population down to 4,956 marsupials. No dramas there. Next question here. It says, show clearly that the population T years after 1997 can also be written as PT. They've got this function notation here, but that's fine. And really all you need to do is work out what's this A and this B value. And this is really a general rule, so different to our recursive rule up here. Here we've just got a general rule where we can jump to any value. And you'll know for a geometric sequence that this value here is just your initial value. So we'll get PT is equal to our initial value of 2000 times by B is the common ratio, which was 1.095 to the power of T. There's your answer. And on your formula sheet, you've probably got this one. Tn is equal to A to the N, where that value there is our T0 value, and the R is our common ratio. And you'll probably also have on your note sheet Tn is equal to A to the N take 1. For this one here, the A value is actually the T1. So you've got the two rules there. But what you can do is just make sure by substituting in, say, T is equal to 0 here, and making sure you do get 2000 for P0, so that you're sure you've got it right. So that's that one done. Finally here they want you to predict the population, when the population first exceeds 10,000. So we can just go back to our general rule here and sub in 10,000. So we put 10,000 in there. We want 10,000. They want it for when it first exceeds. We'll just work out when it's actually is equal to 10,000. So we'll say 10,000 equals 2,000 times 1.095 to the power of T, and we'll solve for T. Now ClassPad does that real easy. So on ClassPad we just pop the solve in there and solve for T, and that'll give us an answer. Let's do that on ClassPad, see how we go. So on ClassPad I'll go back to main menu. There we go, and I'll bring up my keyboard, and there's the solve function over here. So it'll be 10,000 equals, it was 2,000 times 1.095 raised to the power of, you could use that little hat button, or I quite like to use this one on the keyboard, it's nice and neat. And I'll use X instead of T, just for ease of entry on the ClassPad. Move your cursor across, solve for X, and ClassPad will work that out nice and quick for you, 17.73. So you get that T is equal to 17.73. Now you've got to work out, well, what actual year is that? So this is 17.73 years after the start of 1997. And we've already gone through that exercise of 1997 being n is equal to 0, etc. So in actual fact, if T was equal to 17.73, we might want to say, okay, well, let's go to the whole number year. So we go T is equal to 18, the nearest whole number. So we would just go 1997 plus 18 to get the actual year. So that's, what's that? 2007 plus 8, I think that's 2015. And that'd be the start of 2015. Now, that's exactly the same thing as the end of 2014. You can see how this can be kind of tricky working out the year. Those two things are the same. And in actual fact, because it happens at 17.73, just a little bit before that, you'd actually, consider saying even that it happens during 2014. So you might even say, well, in actual fact, it ticks over to that 10,000 during 2014 as your final answer there. Of course, with this one here as well, don't forget you can do this in sequence menu as well. I'll just pop back into sequence menu. Here we go, back to sequence menu. You've already got the sequence in there. Just going to have a look at that table again. There it is, and you can just go down here and have a look and see when it ticks over 10,000. And so you can see after 17 years, it's at 9,355. At 18 there, it's at 10,244. So you can see somewhere between T is equal to 17 and T is equal to 18, it clicks over that 10,000 mark for the number of marsupials, and then it's just a matter of adding those values on and getting it right. So knowing that at the start of 2015, it's gone over 10,000. So at the end of 2014 is when it's gone over 10,000, and sometime during 2014 is when it actually clicks over. And that can be the kind of tricky part that you've really got to think through.